Good morning and welcome to Virtual Classroom Project. It's a collaborative web initiative of Department of Geology, Government VYTPG Autonomous College Durg, and Department of Applied Geology, National Institute of Technology, Raipur. Today we have with us Dr. Neeraj Vishwakarma from Department of Applied Geology, National Institute of Technology. He is going to enlighten us on the subject of various agents of metamorphism. So, good morning, Dr. Sab, and welcome to this session.
Good morning, sir. Thank you very much for giving me opportunity to share my views. As during the previous classes, we have understand the definition of the metamorphism.
Yes.
Now here we are trying to just discussing the various agents of metamorphism. Agents means thus the various factors which are involved in the metamorphism. Say, for example, there are four factors are there. Rather than four, it's a three type factors. One is temperature, another one is pressure,
Mm-hmm.
and third one is chemically active fluid. They are termed as P, T, and X.
Sir.
Pressure, P stands for pressure, T stands for temperature, and X stands for chemically active fluids.
Mm-hmm.
Now, these all factors are agents are only responsible for any metamorphic process.
Mm-hmm.
No doubt, their involvement may vary from
Mm-hmm.
one process to another process.
Mm-hmm.
In some process, temperature is more dominant. In other process, pressure is more dominant. In some process, chemically active fluids are more dominant.
Mm-hmm.
But their their role is very important in each metamorphic process.
Sir.
Now we will see for example, say for temperature.
Mm-hmm.
Next slide, please. Say for temperature, what is the what is temperature? Temperature is nothing. It's a heat. It's
Mm-hmm.
a heat energy. So
Mm-hmm.
heat energy, from where we get the heat energy?
Mm-hmm.
There may be different sources of the heat. One may be any intrusive body into the earth crust
Mm-hmm.
that liberate heat from the itself to the surrounding environment. So any plutonic body or a magma body that may produce heat to
Mm-hmm.
the country rock. Another one is the presence of radioactive decay, presence of radioactive minerals.
Mm-hmm.
Sometimes, in most of the cases, in continental crust or in continental crust, the temperature increases, and due to these temperature, maybe due to the presence of radioactive minerals. So
Mm-hmm.
sometimes these radioactive minerals has the ability to decay. So there is a series of the decays. Series are produced by the different agent minerals are
Yes.
different elements. So
Yes.
when they get decayed, the energy is liberated. So
Yes.
that energy convert into the heat. So
Mm-hmm.
that is the another agent source of heat.
Mm-hmm.
Apart from this, another important factor which and another important factor which controls the heat is load.
Mm-hmm.
Suppose if we go into the depth, the temperature is high because only due to the overlying load of the rock material.
Mm-hmm.
So that is the pressure
Mm-hmm.
of the rock which creates the load.
Mm-hmm.
So if we go now, next one is geothermal gradient. If you see in this figure,
Mm-hmm.
it's the this is here it is a temperature, here it is a pressure, and here it is a depth. So
Mm-hmm.
if we compare the at surface, near surface, the temperature is very low, but as we go deep inside the earth, the temperature is gradually increasing. You
Mm-hmm.
say this temperature is gradually increasing along with depth. So this increase in the temperature with depth is known as geothermal gradient.
Mm-hmm. And the
In
temperature
normal crust,
increases, say, by around 30 degrees, 30 degrees centigrade per kilometer, sir?
yeah, it is, yes, this is the average geothermal gradient of the earth. But
Uh-huh.
in the different part of the earth crust, this geothermal gradient varies. For
Mhm.
example, in each continental crust it is different. For oceanic
Mhm.
crust it is different. In continental margin it is different. In some different type of suppose any spreading grids are there. There the temperature is the geothermal gradient is different.
Mhm.
So it
So,
varies from, but the average.
in a
Sir,
nutshell, sir, this factor or this agent, uh, it has got three sources. One is due to the uprising of magma, which is already
yes,
hot, and
yes,
second, as you have mentioned, the radioactive decay of various radioactive minerals. They
right,
also release heat, and
yes,
the third one is this geothermal gradient, which
right,
which says that as we move downwards or as we go inside the earth from the surface, the temperature goes on increasing with an average rate of 30 degrees centigrade per kilometer. Okay, sir, very
yeah.
nice. So shall we come back to the next agent?
Yeah, this is one agent. This is temperature. Another one agent, another important agent is pressure. Apart from temperature, pressure is also important
Mm-hmm.
because both temperature and pressure are directly proportional to each other.
Mm-hmm.
If temperature increases, pressure also increases. If
Mm-hmm.
pressure increases, temperature also increases,
With some
and vice
exceptions
versa.
like igneous intrusions, I believe.
Uh,
There are few exceptions, such as igneous intrusions, where the magma it comes near the surface, though the pressure is less, but the temperature is more. That is one of the exceptions, is it?
if we see in the terms of magnetism, in
Mm-hmm.
deep-sheeted condition,
Mm-hmm.
the temperature is there, but pressure is also there.
Yes, and near
But
the surface,
but near the surface, temperature is there, but pressure is also less than this. But
so it's
temperature is also less.
maybe one
Temperature
of
is
the
also less.
exceptions. Uh-huh. Right, sir.
I don't think so. But again,
Mm-hmm.
well, it may be. It may be. It may be. But so this may be a pressure. The pressure is an important, but now the pressure is of two different. Pressure is maybe two different type of pressure. It
Mm-hmm.
may be a confining pressure or directional pressure, or it
Mm-hmm.
may be unconfined pressure.
Mm-hmm.
Directional pressure is mean lithostatic pressure.
Mm-hmm.
Lithostatic pressure means the amount of the pressure will same from all the directions.
Mm-hmm.
That is a lithostatic pressure.
Mm-hmm.
Another one is directed pressure or unconfined pressure. Unconfined pressure means the pressure is directional.
Mm-hmm. In some specific
This is
direction.
yes. This is an direct. This is a directional pressure. This is
Mm-hmm.
directed pressure
Mm-hmm.
because at the amount of stress is different from the different directions.
Mm-hmm.
So where generally the deformation takes place perpendicular to the maximum stress direction. So
Mm-hmm.
that is a directional
Directional.
stress.
Sir,
Directional stress,
I remember one example of this lithostatic pressure that suppose if we take a balloon, air balloon,
yeah, yeah,
and if we drawn that balloon into ocean, so
okay,
uh, the more the depth, there will be more pressure, and that pressure will be from the all the directions, and it will be a uniform
yes,
kind of pressure. So
yes,
a simple example of lithostatic pressure, that is just
yes,
by the way. So sir,
yes,
this directional pressure, as you are saying, it creates some deformation along the
yes.
in a direction perpendicular to the maximum.
Maximum stress direction, that is sigma 1.
Yes, sir.
Now the important thing is both type of pressure may commonly exert into the rock.
Mm-hmm.
Lithostatic pressure is mainly due to the ocean basins due to overlying rock load column. The directed pressure
Mm-hmm.
is generally the important thing is the pressure not only increases the temperature,
Mm-hmm.
but pressure always also create some fabrics or structures into the rock.
Oh. Mm-hmm.
So directed pressure, if the amount of directed pressure is more, then definitely there may chances of the foliation and cystosity
Just
development into the rock.
directional properties in the rock. Yes.
Yeah, yeah. So that is why the pressure is also very important into the metamorphic rock. And generally all metamorphic rocks have preserved, they have characterized by an fabric. They have some upward orientation. So
So
this is all this, sir.
pressure is responsible for that. Directed pressure is
Yes,
responsible.
yeah, yeah.
So, sir,
Both pressure. It
next
may be
agent.
directed as well as lithosphere. Next agent is our chemically active fluids.
Sure.
This is again one of the most important factors of the metamorphism, because the chemically active fluids may act as a catalyst during the metamorphic reaction.
Oh.
And generally, in a fluid phase means it is not only water. Any vapor phase that present in the system is known as fluid phase. It may be H2O, it may be CO2, it may be chlorine, it may be bromine, it may be iodine, like anything. But there are two major fluid phases are present into the rock. One is H2O, another one is CO2. These are the most dominant fluid phase presented to the rocks. But both the components H2O and CO2 have a diverse effect. At one end, H2O has a drying agent. It is a weight agent.
Yes.
Yes, if the H2O content into the increase into the system become more and more weighted. But CO2 has a reverse effect. When the amount of CO2 increases into the system become more and more dry.
So
So
one
if we
agent creates hydration or weightedness, and another agent it creates kind of anhydrous conditions.
anhydrous condition.
Right.
So yeah, if we compare H2O and CO2, if we calculate the activity in normal system, H2O water activity plus carbon dioxide activity, both may equal to 1.
Oh.
But for example, in case of earth crust, if the surface of the earth, the H2O content is more. But if we go deep inside the earth crust, the amount of H2O decreases.
Yes. Anhydrous conditions will be developed.
Anhydrous condition creates.
Yes.
So the amount of H2O is decreasing. But the amount of CO2 is increasing with that.
Wonderful.
As we go deep inside the earth, the amount of CO2 increases. So these two factors are more important.
Sir, would
generally
you comment on the source of these two? Source of H2O and source of CO2?
Source of H2O in the rock is from either it may derive from a melt. Every melt has some H2O content, that the hydrous solutions, or this from the surface of the earth, it has the H2O content added to the systems melt. But the CO2 content directly comes from the mantle portion.
As you have mentioned here, that some of the water molecules are present in the mineral structures and they are released during the metamorphism.
Yes, definitely.
Carbon dioxide, the source for carbon dioxide is the carbonates, which are present in the ocean sediments or like that. Well, sir.
Yes, ocean sediments also, but some carbon molecules also present at the mantle portion from where this diamond is coming.
Oh, great.
Into the earth.
Sir, one more term has been mentioned here. It's metasomatism.
Yes.
What would you like to say about this
Actually,
metasomatism?
metasomatism is a metamorphic process. As we have discussed in the metamorphism, the
Mhm,
definition of metamorphism, the metamorphism is strictly a process that always takes place in the solid state.
mhm,
Solid state means no fluid phase is involved.
mhm,
Although fluid phase is present, but their proportion is very less.
mhm,
But if the amount of fluids increases, then some liquid phase may generate.
mhm.
And that particular condition, the metamorphic process does not comes under the purview of metamorphism, it comes under the purview of metasomatism,
Oh.
where the fluid phase is dominant agent.
Mhm. And I remember in the last lecture you had mentioned that metamorphism is the process which has got a closed system. Nothing goes out and nothing comes in. So I think
Yeah,
this metasomatism is a special case or an exceptional case, exceptional type of metamorphism in which
yeah,
fluids play a major role and something is
yes.
added or something is subtracted from the system.
Yes, definitely, definitely, definitely. In metasomatism, it is not a closed system. It is an open system process,
Hmm.
from where in this particular system, the material may can be added to the system or may can be removed from the system.
Hmm.
That is why it is this process is responsible to formation of various mineral deposits.
Hmm.
Metasomatic deposits are there.
Yes. So, sir, thank you so much for this wonderful lecture. Today, what we learned, let us summarize the things which we learned today. Uh, Today, we learned about the agents of metamorphism. And
Yes,
as you told, there are three major agents, the important agents of metamorphism. That is temperature, which is a measure of heat, and second is pressure, and third is chemically active fluid.
fluids.
And the source for heat or temperature, as you mentioned in that part, that there are three major sources of temperature, change in temperature. That is, one of them is the radioactive
One important factor is the
decay
magma
of the
or
minerals,
magma chamber.
and
Second one is the radioactive minerals.
sir,
And third is the lithostatic pressure.
geothermal gradient, you mean?
Yeah, the geothermal gradient is a temperature, that is a grade at
Pressure,
the rate at which the
which
temperature is increasing.
sir.
Yeah,
Then regarding pressure, you mentioned there are two types of pressures. One is lithostatic pressure and another is
right, right.
directed pressure.
Yes,
They have their own signatures on the metamorphic rocks. And
yes,
the third agent is chemically active fluid, and
yes,
it gives rise to a special kind of metamorphism, which is called metasomatism. So
yes.
thank you so much, sir, for this wonderful
Thank
information. And we would like to continue this series of lectures, and we would like to learn from you regarding metamorphic species in the next lecture. Thank you so much.
Sure, 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 sir. Thank you, sir. Thank you very much, sir.